So today I am going to discuss that sound waves are longitudinal waves. Now, but before that, I will revise some of the topic from previous session. We have discussed earlier that when source of sound that produces energy, this nearest particle of medium gets the energy and passes the energy to the adjacent particles. Now, in that we have seen that compression region and rarefaction region, both region occurs and they travel through the medium in order to propagate the sound that we have discussed in earlier sessions. Now, here I have written, like we discussed in previous session, the particle of medium move in direction of wave. We have seen that this particle moves in direction of wave only. This is the direction of wave propagation, and these particles, they passes energy to the adjacent particle. So this movement of particle that is also in direction of wave propagation. Now, when sound wave travels, the air molecule oscillate in same direction. That is of propagation of sound wave. These kind of waves are called longitudinal waves. Means in longitudinal waves, the movement of particle is in same direction of wave propagation. That is the definition of longitudinal wave. Again, in longitudinal wave, the movement of medium particle is in same direction of wave propagation, that are called longitudinal wave. The another type of wave, that is transverse waves. Now in that, the particles of medium or particle of wave that move in perpendicular to the direction of wave propagation. For that, look at the drawing. Suppose it is a solid surface. Now, this one is our string attached to that solid surface. Okay, now what I am going to do, I am going to disturb this balance situation. Right now it is in balance situation. Okay, so what I am going to do, I am going to disturb this balance situation. If I move this string from the another end of the string in upward direction rapidly, what will happen? This movement continues in this direction. It becomes, it becomes like this. The movement propagates up to the second end. Okay, now here you can see the particle of this string move in upward and downward direction. So the direction is like movement direction, movement of string, that is in upward and downward direction. But the movement of this wave, it is in this direction. You can see both are perpendicular to each other. Propagation of wave, that is in horizontal direction, and movement of string particle, that is in vertical direction. So both are perpendicular to each other. These kind of wave that are called transverse waves. You can see here the definition: transverse waves. Waves that vibrates perpendicular to the direction of wave propagation that are called transverse waves. Now light particles are transverse waves. Now again look here, this is the same figure. You can say this one is our compression region, means here the density of particle is high, also pressure is high. This region, these two region are rarefaction region. Okay, means here density and pressure are low. Now if I draw a graph of density versus distance, you can see the first region is compression region, means density is high. So here I have drawn here density is high, you can see here in the graph. Now gradually density is decreasing here up to this mark. Okay, so you can see density is decreasing. Then again density increases here up to this part. So you can see density again it is increasing. Then again density decreases. Okay, this part continues up to this sound reaches to hearing ear. So this is the graph of density versus distance. Now this is called sound wave. This line, this middle line, that shows the average density. You can see it is in middle of these two part. Okay, it is the midpoint of this height, so it is average density. Now this graph is helpful to understand some of the definitions that I am going to discuss here. Now in the graph of density versus distance, rarefaction are the region of low pressure where particles are spread apart and are represented as valley. Means here you can see the density is lowest here, density value is lowest here, so this part is called valley. Same way in the graph of density versus distance, the compression are region of high pressure where particles are compressed and are represented as crest. Now in this graph, this is the maximum height, maximum density points. So these are crest. Okay, this is also valley. Lowest density means valley, highest density means crest. Now definition is there: distance between two consecutive compression or rarefaction, that is called wavelength. Means distance between two consecutive valley, this distance you can see, this distance, two consecutive valley or two consecutive crest, distance between these two, that is called wavelength. Now wavelength, it is length only, so unit for length, that is meter, and wavelength is denoted by lambda. This is the sign for lambda. Okay, now as shown in figure, density is high in compression region, then it lowers down. You can see this is compression region, then density gradually lowers down. Okay, that is lowers down and becomes minimum. Here the density becomes minimum. You can see in this figure. Then it starts increasing. Again it starts increasing and becomes maximum here it becomes maximum. So this is one oscillation. You can see here from graph also you can understand. Let me draw the graph again. You can see density, this is density and this is distance. Now here you can see density is maximum, then it lowers down up to minimum value, again it start increasing and reaches to maximum, then again it becomes lowest value of density. Okay, it decreases up to minimum value of density. Now here you can see this distance, this is one oscillation. Here density increases, then again becomes minimum. This is one. As shown in figure, density is high in compression region, then it lowers down and becomes minimum, then it starts increasing and becomes maximum again. This is one oscillation. Now from that, a definition is that definition of frequency. You can see number of oscillation of sound wave per unit time, that is called frequency. The frequency is denoted by mu. This is not V, this is nu. Again, the definition is like this: number of oscillation of sound wave per unit time, that is called frequency, and it is denoted by nu. Unit for that is hertz, Hz, capital H, small z, hertz. It is scientist's name, hertz. And the next definition is time period. The time taken to complete one oscillation, that is called time period. This is the relation between frequency and time period. V is equal to 1 by T. That is the relation between frequency and time period. Okay, so that's it for today. Thank you.